Hey y'all, it's Miss B. Let's do some math together, okay? Today we are going to talk about potential zeros. And these are just possibilities, all right? So if you will remember, zeros doesn't necessarily mean the number zero. In this case, what we are talking about is we're talking about zeros or roots or x-intercepts. So in terms of the zero, the y value is zero, but the x-intercept is going to be something different. It could be a different number. Okay, so if we talk about zeros, roots, or x-intercepts, we are talking all about the same thing. All right, but what we're going to do is we're going to narrow down our guessing. Okay, we're going to take a polynomial and we are going to list potential zeros. All right, in order to do that, what we need is we need a p and a q. Okay, p is always going to be the constant of the function. It's going to be that number without a variable. Okay, so in this case of this mild problem right here, we're going to look at this number 3. Okay, we're not going to be super concerned with the signs right now. We're only concerned about the number, but I've got it there just in case. All right, the next part we're going to look at is the q. The q is always the leading coefficient. Okay, that's the number in front of the variable with the highest exponent. So my leading term is x to the 5th, okay, because that's my highest exponent. And so my leading coefficient is this guy right in front. We don't see anything, so what we do is we assume the number 1. Okay, so just to write everything out like a little shopping list, I have my P is equal to a 3 and my Q is equal to a 1. Okay, and what we're going to do to find all of our zeros, our potential zeros, is we are going to list out all of the factors of 3 of our P, and we're going to list out all the factors of our Q. Okay, so the factors of 3 are going to be 1 and 3. Those are the only two numbers that go into 3 equally. And then for Q, the only factor I have is 1. Okay, so you have to put all the factors of P, which is your constant, over all the factors of Q. That's your leading coefficient. Okay, then you're just going to parse them all out. So for instance, I'm going to do 1 divided by 1. So I'm going to put all of my factors of P over all my factors of Q. So I started with 1 over 1. That's equal to 1. And then I'm also going to share 3 over 1. 3 divided by 1 is 3. Okay, that's it. I don't have any more factors. So the last thing I'm going to do is I'm going to put a plus or minus in front of the 1 and a plus or minus in front of the 3. Because I told you earlier, we didn't have to take care of the signs. We didn't have to worry about them. Because when you're listing potentials, it's always going to be both the positive and the negative. Okay, so if I were to list them all out, I would say that I have a potential 0. Potential roots of this polynomial are 1, -1, 3, and -3. Okay? You can write it either way. Both will be accepted. All right? Let's take a look at one that's slightly spicier. Let's take a look at a medium one. Okay? The only difference between the one we did for mild and this one is we have a leading coefficient that's not 1. That's the only thing that makes this a little bit more complicated. Again, your process is the same. So we still need our P and our Q. Okay? So in this case, our P is 6. Again, that's our constant, sorry. And then our Q, our leading coefficient, is 4. Again, remember, we don't have to worry about the sign part because we're going to add it in at the end. Okay, so start off, I'm going to list all of my factors of 6, all the numbers that go into 6 equally. So I've got 1, 2, 3, and 6. For 4, for my q, I'm going to do 1, 2, and 4. So you see we have more options here, okay? But we're still going to do the same thing. We're going to put all of our factors of our p over each factor of our q, all right? And we're going to notice that we're going to get some repeats in there. So starting off, I'm going to do 1 over 1, so that's just a 1. And then I'm going to do 2 over 1, so that's just a 2. And then I'm going to do 3 over 1, so that's 3. And then I'm going to do 6 over 1, so that's 6. So I put all 1, 2, 3, 6 over 1. Now I'm going to put 1, 2, 3, 6 over 2. So I'm going to do 1 over 2. Do this in different colors. 1 over 2. So that's 1/2. And then I'll do 2 over 2. Well, 2 divided by 2 is 1, and I already have that one, so I'm not going to write it again. Don't have to write it twice. Then I'm going to do 3 over 2. And I'm going to leave it, excuse me, I'm going to leave it as a fraction, an improper fraction. It makes your math easier later on. Then I'm going to do 6 over 2. 6 divided by 2 is 3. I already have 3, so I'm not going to write it again. Okay. Last but not least, we have to put everything over 4. Okay, so it's going to start getting messy with the highlighters, but I'll keep track, okay? 1 over 4. I don't have that one, so I'm going to copy it. And then I'm going to do 2 over 4. Well, 2 divided by 4 is 1/2. I already have that one, so I'm not going to write it again. 3 over 4. I don't have that one. And then last but not least, 6 over 4. 6 divided by 4 is 3/2. Again, I already have that one, so I'm not going to write it again. Okay, so these are all my potential zeros. And then remember I said the signs will come at the end. We just have to put the plus or minus in front of all of them. So to make sure we know, it could be +3 or -3. It could be +6 or -6. All right, so we're just going to put the plus or minus in front of all of them. 4th, plus or minus 3/4. These are all the potential zeros, the possible roots of this function, okay? The next video you guys will see, I'm actually going to go through on how to take these potentials and find all of the roots of a problem. But I wanted to show you guys this is the first step. You find your possibles, and then that narrows down your guess and check, okay? Leave a comment and a like. Let me know if you want another example of this, of the same thing, something different. Otherwise, I'll see you guys next class. Bye.